Hello students! Today we're going to have a focus on factoring trinomials with two variables. It's actually very similar to factoring trinomials with one variable. We just have to make a little bit of a modification. So what I want to do is I want to look at two problems together. I want us to factor x squared minus 3x minus 10. And I also want us to factor x squared minus 3xy minus 10y squared. The first one is one that we already know how to factor, and we're going to use that to see how we can factor the second one. Now, this trinomial is in the form x squared plus bx plus c, so we know that we should be able to use unfoiling and write it as a product of two binomials. It's going to be x plus one number and x plus another number. And we know two things about those numbers that we're looking for. The product has to be negative 10, and the sum has to be negative 3. So we're looking for two numbers with a product of negative 10 and a sum of negative 3. And those numbers end up being negative 5 and 2. They do multiply to negative 10 and add up to negative 3. So the factorization is going to be x minus 5 and x plus 2. Hopefully that wasn't very difficult. We've seen several examples like that. Now we're going to look at something similar, but this is different. It's got two variables, not just an x, but also a y. And it follows a very particular form. The first variable is squared in the first term. The other variable is squared in the last term, and both of the variables appear in the term in the middle. When this is the case, we can factor this just like we would without the y, but we need to change things just a little bit. It's not just going to be x minus 5 times x plus 2. We're going to have to alter things. And the reason is, if we were to check this by foiling, when we multiply the first terms, x times x gives us x squared. So that works out. But if we look at the last terms, negative 5 times 2, that gives us negative 10, but we want negative 10y squared. So how can we change what we have to account for the fact that the negative 10 has a y squared on it? And the answer is by putting a y on each of these numbers, x minus 5y and x plus 2y. I'm going to show you why this works. Let's FOIL it out to check. Again, when we multiply the first terms, we get x squared. That's good. The outer terms, x times 2y, gives us 2xy. The inner terms, negative 5y times x, gives us negative 5xy. And the last terms, negative 5y times 2y, is going to be negative 10y squared. And we can see that by putting these two y's here, we end up having a y on the outer and inner terms, so that when we combine these, negative 2xy plus 5xy gives us the negative 3xy that we need. And then also by taking those two y's, we end up with a y squared in the last term. So whenever we have an xy in the middle and a y squared, we can alter the original factorization, x minus y times x plus 2, by putting a y in each of those constant terms, and that's going to give us the y squared we need here and the xy that we need there. Let's take a look at a couple more examples to get some practice. Let's factor c squared minus 3cd minus 4d squared. Again, this looks sort of like something that we would unfoil, because we've got a variable squared without a leading coefficient in the first term. So if those d's weren't there, it would be c plus some number, and c plus another number. But because the d's are there, we're going to have c plus some number times d and c plus another number times d. Now we need to find those numbers, and we know two things about them. They have to have a product of -4 and a sum of -3. Can you think of two numbers that have a product of -4 and a sum of -3? Well, it looks like -4 and +1 will work. So our factorization is going to be c minus 4d, and then c plus, and you can write either 1d or just d. Doesn't matter either way. It's the same. And so this ends up being our factorization. It's just a little tiny bit more involved. All right. Let's take a look at another one. Let's factor 2a squared plus 5ab plus 2b squared. This one might look a little bit more complicated because there's a leading coefficient. However, this is something that we're already capable of factoring. We're going to have to use the AC method because we have a leading coefficient here, but the AC method isn't any different when we've got more than one variable. Let's go through the process of the AC method. A times C in this problem is going to be 2 times 2, which is 4. B is going to be 5. So we need two numbers that have a product of 4 and a sum of 5. Those numbers are going to be 4 and 1. We're going to use them to split up that middle term. So we've got 2a squared plus 4ab plus 1ab plus 2b squared. And then we can finish off by grouping. The GCF of the first group is 2a with leftovers a plus 2b. The GCF of the second group is just b with leftovers a plus 2b. And so the GCF among the groups is a plus 2b. The leftovers are 2a plus b. And this is our factored form. As always, I want you to take a look at the videos linked below to go through some of the other examples, because you're going to see some things in those examples that you didn't see in these very first problems.